The second of the 23 problems that Hilbert announced in 1900 was to prove the consistency of the axioms of arithmetic. What does this mean, and why would you want to do it? Well, the axioms of arithmetic are very simple statements like 0 is the first number, every number has a successor, and yet from these you can derive all of arithmetic, multiplication, addition, subtraction, and so on. And you might be happy that all of these axioms sound okay, but Hilbert was worried that if you cranked through enough proofs, you might somewhere find something that's inconsistent. You might get one way of cranking through the proofs using these axioms that showed you one thing, and then another legitimate way that showed you its opposite. And so he just wanted to show that that wasn't possible. So what happened? Well, about 30 years later, Gödel proved two incompleteness theorems. Now, the first incompleteness theorem showed that within mathematics, with any formal language with sufficient power, like the language of arithmetic, there are statements which you can make and yet can't be proven. A very simple example of this in human language is, this statement cannot be proven. And his second incompleteness theorem showed that you cannot prove the consistency of a language with these powers. So you just can't show that this language is not going to lead to inconsistency. And arithmetic is exactly this sort of language. So we didn't disprove, we didn't show that the axioms of mathematics are inconsistent, but we did show that they cannot be proven to be consistent.